An aircraft produced by Bell is on the way to becoming the next armed reconnaissance helicopter for the United States Army. Its main rival is the Sikorsky's Raider X. Bell claims that they have completed more than 90% of their prototype, the 360 Invictus helicopter. Keep watching till the end of this video to see U.S. high-speed attack aircraft will defeat China. To fulfill the United States Army's need for a future attack reconnaissance aircraft, the Bell 360 Invictus is a proposed aircraft design. The Bell 525 Relentless served as inspiration for the development of this product. The helicopter's wings extend out from either side of its slim main body. This sort of wings would not often be found on a helicopter. However, Bell included it for a reason. The Army wants this bird to be capable of speeds greater than 160 knots or 184 miles per hour. The phenomenon of retreating blade stall becomes a problem when a helicopter attempts very high speeds. When a helicopter is flying ahead through the air and the rotors are spinning in circles, one rotor blade always travels against the flow of oncoming air, and the other is always moving with the flow of receding air. The amount of lift generated by the rotor blades at any particular orientation may change as a result. This is the same reason why Sikorsky's design includes two top rotors that rotate in opposite directions. When the approaching blade generates greater lift than the retreating blade, an unstable, dissimilar lift condition is created, as described by Geller. According to him, the problem usually arises when the rotor blades are rotating so quickly that the speeds of their tips approach the speed of sound. According to Geller, this is where the lift-sharing wing comes in handy. Past the 160 knot mark, it contributes roughly 30% of the lift required by the helicopter. In response to the wing's increased lift, the helicopter's rotor can spin more slowly, preventing blade stall. The Invictus would still be moving at a high rate of speed, but the rotor blades could fly at a more manageable rate without endangering anyone. Another consideration is the angle at which the rotor blades bite into the air. The wing on the Invictus allows the reversing blade to be positioned at a more aerodynamic angle. The Army has stated that it will decide which aircraft to use in the fiscal year 2025, and the engine for that aircraft has already been selected. The model number for its generator is GE T901. Nonetheless, Bell has opted to pair that primary computer with a secondary one, or an SPU, or Supplementary Power Unit. This tiny engine functions similarly to an aircraft's auxiliary power unit. While in flight, the SPU can also function as an extra engine, which Geller points out about the Bell's design. Before anything else, this engine functions as a conventional auxiliary power unit, or APU, to kickstart the chopper. However, we clutch it into the drive system, and that allows us to supply power into the drive system at a hover at high speed at any time the pilot might require it, he says. Like the main engine, this one consumes jet fuel to generate power. Its output is anywhere between 600 and 900 horsepower. The primary engine, manufactured by GE, will provide 3,000 shaft horsepower. Based on the power output of the main engine and the auxiliary power unit, Geller classifies this plane as a 1.25 engine aircraft. In the event that the main engine fails and an emergency landing is required, the SPU can also be used to assist the pilots. He explains that the auxiliary power unit would activate and power the rotor system for a gentler touchdown. However, while it won't be able to keep the bird aloft for good, it will offer the pilot more time and more options to land safely. According to Geller, the Invictus will make its maiden flight in the fall of 2023. Just released photos show off the new helicopter's stealthy design, which includes a rounded fuselage, a single rotor, a tail rotor in the back, and an internal weapons bay. These features are meant to decrease the helicopter's radar signature, boost its speed and agility in the new sensing and targeting paradigms, and allow it to fire an entirely new class of long-range pinpoint air attack weapons. Developers say they're 90% of the way through construction, and Bell engineers are just waiting for the new, more efficient and powerful improved turbine engine, or ITE, or T901 GE900, to arrive. The assault helicopter will be nearly ready to go once the engine is delivered. The Army's new aircraft will fly alongside and maybe replace some updated Apache attack helicopters, and the Bell strategy aims to accommodate, anticipate, and potentially advance Army requirements for the new aircraft. Bell's Invictus 360 and Lockheed Raider's Sikorsky's X-Farah are now being tested and evaluated by the Army. Although it is known that the Invictus 360 helicopter can launch Hellfire, JAGM, and other state-of-the-art weaponry, what other capabilities it will have in the future is less certain. Since new forms of weaponry such as lasers, EW systems, in-flight course correction enabled by AI, and longer-range, more precise targeting are appearing rapidly in the context of evolving technology, this may be on purpose. Since this is the case, it stands to reason that the plane will be constructed with an eye on future upgrades in mind. However, the Army has established explicit specifications for Farah to fire a 20mm gun, therefore not all is unknown regarding the aircraft's potential armament configuration. Air launch effects, miniature and medium-sized attacks, and surveillance drones will be launched from the inside weapons compartment, a feature highly desired by the Army. The Army's experience with Project Convergence in the Arizona desert in 2020 showed how effective miniature drones might be in identifying targets, transmitting real-time intelligence data and video, or even exploding enemy objects from a forward position from a human-operated aircraft. As such, they played a crucial role in the Army's successful AI-enabled networking kill web during Project Convergence, which reduced the time it took to go from sensors to shooters from minutes to seconds. Weapons and payload. With its 82-inch long payload compartment optimized to reduce drag while simultaneously carrying weapons and ALE, the Bell Invictus 360 was designed from the ground up to carry out its job. The radar signal of the helicopter can be decreased thanks to the helicopter's payload storage and internal weapons capacity. Obviously, sticking out sharp edges and shapes like weapons, pylons, or angled configurations will render or return signals more clearly for enemy radar, while the 360's full stealth capabilities remain classified for logical security concerns. The aircraft's outwardly apparent shape and internally accessible weapons bay suggest it has some degree of stealth capability. The current Army Apache, for instance, is characterized by a crisp, rectangular-like form and jutting angular armament pylons, neither of which can be observed on the Bell Invictus. With the landing gear and weapons pylons stored within, we don't deploy the weapon systems out in the air to produce drag until the pilot needs to utilize them, Keller said. A longer multi-purpose payload bay appears rather significant, as it allows for the probable deployment of a broad variety of weaponry and also for the launch of mini-drone targeting and attack ALE. For this purpose, Bell has been collaborating with the military. The wing's design permits the cargo mechanism to extend out here where the armament systems may be retrieved. When that happens, you'll have an equal opportunity to fire from each flank. Geller noted that the clearance on the deployment of the ALE is possible because of the partnership with the Army and the manufacturers. The strategy behind the design is to create a helicopter that can be modified and updated when new technologies become available. This includes the helicopter's mission systems, targeting systems, avionics, and armament systems. Developers at Bell define this as a modular open systems architecture, or MOSA method, in which a shared set of technological standards is implemented to provide continuous upgrades and adaptations, like software updates and weapons upgrades. What you see is the airplane that is pretty well complete, minus functional inspections, and the engine looks terrific, Geller said. We can begin the development of the next weapon system even while we're obtaining information of the competing prototype right now. There's not a lot of information available about this new stealth aircraft, but the information that is available suggests that it has the potential to become the most advanced stealth aircraft ever, but it will not be possible to find out until the year 2023. Can Bell's 360 Invictus become the best stealth helicopter ever? If you like this video, make sure to smash that like button and subscribe to our channel for regular military updates. Don't forget to leave a comment in the section below. Thanks for watching.